Okay. Then okay, no, we can start.
Yeah.
Okay.
So today I will start with chapter 2. So today we will discuss basics of heat and all, and how to derive tonnage 12,000 BTU per hour and kilowatt 3.517. All those things we will derive. Okay, before
Okay.
that, you are able to see my screen, right?
Yes, clear. We can see it.
So chapter 2. So basics physics in HVAC. Okay, physics in
Okay.
HVAC. So we will be discussing heat. Mainly yesterday also we discussed that what is heat, form of energy and units and all. It's extended form of heat. Okay. So heat we will discuss and its units. Okay, units we will discuss. And what else we will discuss? We will discuss about the temperature, BTU, meter, units we will discuss. Then modes of transfer, heat transfer, correct? Modes of heat transfer, and type of heats. So, for example, we have sensible heat, latent heat. So, all those things we will discuss. Type of heat. Okay. And so, this is one concept. This is very important. This we will discuss. And second one, we will discuss about tonnage, basically how to derive the tonnage or units of refrigeration, let us say. Okay. Units of refrigeration. So BTU per hour and kilowatt and its derivation. Okay, and third we will discuss about the temperature.
Shiva, for that point number 2,
Yeah.
Kilowatt and
BTU per hour.
what's
BTU and its derivation. See how to derive. See, for example, derivation, how to derive. Got it? See, 1 TR is equal to 12,000 BTU per hour. Okay, in the interview, they may ask how you got 12,000 BTU per hour. You need to tell something, right? And 1 TR
yes, correct.
is equal to 3.517 kilowatt. They will ask how you got 3.517. So, all those things we will discuss. Okay. And the third point is temperature.
Okay.
Temperature and units. Units of temperature and conversion. Conversion between degree Celsius to Fahrenheit and vice versa. Fahrenheit to degree Celsius. Okay, this we will discuss. Okay, if the time left then is still there, then we will discuss zeroth law of thermodynamics, all those things are there. But let us focus on this. Okay, so let us take first one, what is heat? So we have defined heat is a form of energy, basically. Form of energy which always transfer from higher temperature to lower temperature. Temperature to lower temperature. Okay. So what is unit of heat? Joules or calories or BTU. Okay. So this is basically heat. Then this is, we discussed heat and units, and let us go to modes of heat transfer. What are the modes of heat transfer? Any idea?
Convection,
Yes. Conduction, convection, and radiation.
radiation,
Yes.
convection.
Yeah. So
This
let
one?
us, yes, correct. Conduction. Okay. What conduction means? If two solid bodies is there heat transfer between the two solid bodies, it is called as conduction. Heat transfer between two solid bodies. Okay, but there is no phase change.
Correct. No phase change.
Okay. So let us give some examples. What? See, when you touch, when you keep hot metal, okay, hot metal, to beside any, it may be wood. Wood is insulator, but it is a solid body, and if you touch any hot metal and if you touch this surface, then you feel hotness. Correct? Or if you place this
Correct.
on any table, okay, then afterwards you take it out and you can feel that it is hot. Correct? So this is basically conduction. Okay, so what we can give as some examples. So, and also when you put your hand over the burners, then you feel hot. Correct? So that we can keep in conduction.
Yes, correct.
Okay, but it is flow of fluid, right? So it is due to movement of the fluid that we cannot give. So, but ice cubes which are placed on the table, okay, then the table becomes what? It will become cooler. Then you can see the condensation. You can dew points, dews which are formed over the table that you can find. So that you can give an example. Okay, and doing ironing. Okay, you can write. We will write. Okay, ironing is the best example what I feel, because what I feel day to day things. Let us focus on day to day examples. Okay, then it we feel that yes, we will feel confidence, right? When we have examples of conduction for the day to day life. Which is, hello, you are there, Mohanad?
Yes, with you. I'm with you.
Okay, let us write some examples. Ironing, ironing of clothes. Correct. Okay, iron is a solid
Yes.
particle and you are doing ironing of clothes. So solid to solid.
Mm-hmm.
Then uh, mm, table gets heat once table gets warm up. Warm up. When you place a tea cup or coffee cup, warms up. When you place a hot cup of tea, hot cup of coffee or tea. Okay. So anything else you can give? Ice cube also, ice cube example you can give.
It's that will be in between. It will transfer between two things, two bodies.
Yes, two bodies, solid bodies. See, for example, okay, this is a pan. Okay. And if you are heating this, okay, and this will warm up. Okay, this handle also will get warm up because of this fluid or liquid. This liquid transfer its heat to this metal. From this metal to this metal, this is handle. You will get, this is conduction. What happened?
Okay, it's clear.
Yes. So this is one. Okay. Then second one is convection. Heat transfer, or I can say heat transfer due to movement of fluid. Heat transfer due to movement of the fluid. Fluid means you know, right, whether it is air, gaseous form or water. That is called as fluid. Okay, it may be air or water. We call it as fluid. Okay, here what is happening? Convection is happening. So this is the liquid and this is the water, so solid body, or
Yes,
I can
correct.
say it is a pan. So the heat transfer is taking place between this liquid to solid. Okay, from liquid to solid. So this is, here you can say it is convection. Okay, so this example you can take our hair dryer. Best example what I usually give is hair dryer. Okay, if you go in front of fridge and open the door, then the inside air will come and hit you. Then you feel colder. Correct? So that is also an example you can give. I think in from your end, is there any internet issue? Is there, Almona? Hello.
Clear. No,
Your voice is not clear, so I thought there is some internet problem from your end. If
no, I
you're
don't know. Maybe my voice reached there to you
later, correct?
late.
Yeah. But my
Yes,
voice
yes.
is clear to you.
But the screen is, yes, yes, and screen is it's okay on time.
Screen is also okay, and my voice is also okay. No problem for you.
Yes, yes, no problem for that.
Fine. Then I will go on proceeding with the syllabus. Huh? Okay. So then third one, what I can say is
Okay.
radiation. Radiation. So heat transfer due to electromagnetic waves. Heat transfer due to electromagnetic waves. So for example, this is heater is there. Okay, electric heater. So the heat will be transferred through electromagnetic waves. Or for example, sun is there. Okay, and it will reach to your home by what? It is called electromagnetic waves. If air is there or not, water is there or not, heat will be transferred. Okay, so this is by electromagnetic waves. Okay, Then example what I can
That
give?
molecule and this element, small element, it will be
Yes.
moving.
No, but
We'll
we
see.
call it as it is not. It is a wave. It is not
It's
basically
wave, yes.
elemental. It is not a atom to atom movement. It is a waves.
Okay, clear.
Okay. So when you go out in a sunny day, then you feel hotter because of solar radiation.
Correct, correct.
When you go out, you feel hot because of solar radiation. Okay, I think we have finished this heat transfer, modes of heat transfer. So let us discuss with types of heat. Shall I clear this? Hmm?
Yes, yes, you can clear.
Okay, so now we will discuss with types of heat.
Yes, yes, you can clear it. Clear.
Sensible heat and latent heat. Latent heat. So what is sensible heat? So when you give heat to a substance, the temperature of the substance will increase. Okay. The temperature of the substance will increase.
The heat that we can sense by our body, right?
Sensible heat, if you give a heat, whether you give by electrical stove or gas stove or something, if you give a heat to any substance, okay, then the temperature of the substance will increase. But there is no phase change. There is no phase change. It is called as sensible heat. Then what is latent heat? When you give, when you supply a heat to a substance, then the temperature will not increase. Temperature,
The RH, right? It will be increased.
we can say no, it is not RH actually. There is a phase change will be there. Okay, if you give, see, for example, water, 99 degree up to 99 degree Celsius, the water is water itself. Okay, that is, if you are giving heat to water, okay, up to 99 degree, it will say it is what? Sensible heat. If you give 100 degree, then vaporization will start. Okay, that heat which you are supplying only between 99 degrees Celsius to 100 degrees Celsius, that is called as latent heat. Okay, see, temperature of the substance will not change, will not increase, only phase change will be there. Okay, so this is called sensible heat. Okay, and example, how, what and all you can give examples. See, for example, what will happen, this is sun, okay, and this is your home. Say for example, see, heat will come from outside to inside. Correct? See, because of temperature, for example, in Oman and all, it will be 50 degrees Celsius. 50 degrees Celsius, this is outside temperature. So this outside temperature will go here, inside. So this is heat gain. Okay, this is sensible, you can sense it. Okay, this
Yes.
is basically sensible temperature is you can sense it. That's why the name has come as sensible temperature. Okay, so this is, I can say, heat gain through wall or windows. So second one, heat gain through what I can say, solar radiations direct. Solar radiation. And heat gain through electrical equipments, energy consuming equipment. Say for example, bulb, fan. Okay, all those things, they will take electrical energy and they will heat dissipate. They will dissipate heat. So that is also sensible heat.
Okay. Correct.
Yeah. So heat gain through electrical appliances. Electrical appliances. Energy consuming appliances. Electrical or energy. See, they will consume energy, electrical energy. Then they will dissipate heat. Heat dissipation.
The equipment, you mean?
Yeah, it may be laptop or desktop. All the,
TV and these things.
yes, yes. Heat dissipation of energy consuming equipments. Okay. So these are all the examples. So, and human, see, we also dissipate heat because our body temperature will be there, right? Okay. For example, your body will be almost 32 degrees Celsius.